All right, welcome everyone. My name is Paul Yu, and really want to talk a little bit more about how RAMP is managing access and authorization in the cloud, particularly to achieve least privilege. And so I lead our security assurance team here at RAMP, and I'll give a bit more information on what that means for us. But before we do that, I wanted to give a bit of context of what RAMP is and provide that level of context to help understand why managing access and authorization and really obtaining least privilege is important for us. And so RAMP, our goal is to build a platform for modern finance teams, and we brand ourselves as a finance automation platform. I'm sure many of you on this call may have used different expense management platforms, and just throughout the years, the challenges and the friction there is in submitting your expense reports, and even from finance teams, building a lot of the automations has been particularly challenging over the past couple of years. Now, as RAMP builds this finance platform and really builds automations into all those platforms, we connect to a lot of different systems, from your HR systems to your banks, to your ERPs, and to different business tools. And you can see just even from the screen, the amount of information that RAMP collects in order to provide our service to all of our customers. We need to collect information of the employees at a company, so we know who to issue cards and who we can issue spend to. We connect to your bank account so we can make bill payments and vendor payments. And so a lot of our customers trust us with their most sensitive spending data and a lot of their KYC data and a lot of PII. And so for RAMP, our goal for our security team is to be able to earn the trust of our customers and maintain the trust of our customers. And so in order to provide our services, as I mentioned, we collect a lot of information, and we want to do our best to make sure our customers can really trust us. As we all know, it's really easy to lose trust, but hard to keep it and to maintain it. And so my team here at RAMP, we are the security assurance team. We're broken out into three main pillars. The first is cyber risk management, the second is mission enablement, and the third is compliance engineering. And our talk today is really diving deeper into the third pillar, which is data security and governance, and our identity and access management strategy. Because our goal for our security assurance team is to move beyond just compliance and moving past compliance into real security. Now, before we dive a little bit deeper into that, I want to set continually a little bit more context of the landscape of the systems that we use here at RAMP. If you can notice just from this graph, when RAMP first started as a company back in 2019, we really had a very limited amount of SaaS tools and different systems that we use, different systems that are housing data and so on. But as you can see that over the years, as our company has grown and as our org has increased substantially, so has the number of SaaS systems across the board. And so initially, the problem was, how do we manage access and authorization to 30 systems? That has now increased to hundreds of systems. And so you can see there's a scaling problem that exists, and there's a real data access security problem in just really 10 times the amount there was when RAMP first started. And so within each system, there are groups, and within each group, there are people, and within each people, they're assigned a particular role, and that role has a set of permissions. And this is easy when you have 1 or 2 or 5 systems that you have to manage, but gets particularly challenging when you have hundreds of systems to manage. And so scale is huge, momentum is against us, and it gets challenging to manage this. And we can't just have infinite amount of people working on this. So we needed to solve the problem and really think about strategically how we can manage access. And going back to what I said, a lot of what we built initially and historically across many of our different organizations is we wanted to meet really compliance requirements. But now the way we're thinking about it is how do we move from compliance and go beyond compliance to real security? And we still see value in compliance. There are minimum standards that we want to meet and we want to be able to really work toward, but we want to move beyond just compliance to real security, to build real security processes and to help reduce our attack surface and increase our overall security posture with the goal in mind of protecting all the sensitive information that our customers trust us with. And so I want to break this talk out into two main areas. First one is how do we manage access and auth for all of the SaaS applications that exist within our organization? And then secondly, as a subset of that, how do we implement the least priv program for our cloud production access, which is the most sensitive system that we have here at Ramp. And so first, getting started with some of the SaaS applications. When you look here, just in our early days, the way that we got access to a lot of our systems is we had to, one, message in Slack directly responsible individuals or DRIs to give us access to a particular system. And then that moved to this manual ticketing process. As that evolved a little bit, we moved into this Okta self-service model. And this Okta self-service model was, once we got Okta in place, we had SAML and SCIM in place and implemented for a lot of the integrations that were available. And we can, users and employees could request access via the self-service module. But then there were a lot of applications that lived outside of Okta where you still needed to go through this ticketing, and we used a tool called Assist, and you had to request a ticket. The IT team had to then go identify the directly responsible individual. They had to get their approval. Once their approval was received, they have to provision the access, and then they have to close out the ticket. And so that is about 5 to 6 steps involved for every single access request, times that by hundreds of systems, times that by hundreds of employees. And you can see that the mass begins to be quite large. And as we were thinking about this, there were a couple problems that we wanted to solve. The first is we didn't really have a lot of visibility into all of our applications, particularly for those applications that were living outside of Okta. And so we knew what was in Okta, but everything outside of Okta, we didn't really have a good grasp on. Second, the way that Okta and Okta self-service worked was there was, at the time, no time-based access. We wanted to move toward this just-in-time provisioning model where employees could request access for a set threshold of time. But if you wanted access, it was either you have it or you don't. And there was no real in-between. As I mentioned, kind of looking through historically, our early days in the self-service model, there were still heavily manual processes, and there was a real need for automation. And then lastly, we wanted to really centralize this process. Previously, you had to either go to Okta, you had to go to Slack. There were a lot of different places you needed to go to really get access to all the systems at Ramp. And so these were the problems that we identified. And this is the team that was really trying to tackle that problem and think through some of the solutions for those problems. And while we were thinking, there was this ideal system we had in mind to meet the 4 problems that we had identified in our search. But particularly, our main goal for a lot of what we were building were happy users and happy engineers. A lot of times when you think about how security is implemented and how security is scaled in an organization, that comes at the cost of the people working at your company, where we implement a security solution, but it creates more friction and it creates unhappy users. And so while we were thinking about this, we wanted real security, but also to help streamline it, to help enable the users at our org. And we wanted those things to go hand in hand. So our ideal system had to meet all of these 3 things, visibility of just-in-time and automation. But it wasn't a successful system if it caused too much friction for our users, which would lead to unhappiness. And so what we did is we used a tool called Conductor One, and here's a demo that I recorded, and I'll kind of talk us through the demo as I go through it. But this demo is to kind of show you what we did to really tackle and practically solve for the problem that we were facing. Now, if you see on the right, this is our IT FAQ how-tos. This is a demo application that our IT team built. And every user, when they join RAMP for the first time on their first day, learns how to use Conductor One to request access to our applications. And so if we see right now, I'm trying to search for myself, and I can see that in Okta, I don't actually have access to the IT FAQ app. And so what we're going to be doing now is then we see kind of in the back end how this is configured via Conductor One. And Conductor One is a identity governance and access management tool that sits on top of Okta as our IDP. And we see that this IT FAQ app is managed, and I'm set as the application owner. We see that the source is Okta or IDP. And then we have an approval policy where the app owner is approving all requests. So previously, we had to go and we had to find the application owner, but now here it's programmatically configured so that every request for this application then gets really sorted through Conductor One, and then it automatically alerts the application owner to approve access. And so what I'm going to do next as part of this demo is I'm going to request access to this application. Something to note here, one of the success criteria for a tool and a process for automation is we wanted just in time. And so we wanted different threshold for which you could request access. One of the challenges you find is that if you want to give someone access for an hour to a system, you'll not only need to solve for provisioning, but you have to solve for automated deprovisioning, because no one's going to sit there, give access to someone, wait an hour, and then remove access. And so the way that Conductor One works is you can select an hour, 12 hours, different time periods you can set for a person to request access. Sometimes there's this indefinite because there are real use cases where users need to have indefinite access to a system. And so you can select whichever time that you want, and you can give a reason why this access is needed, and then you could submit the request. And then here on the left, automatically, you can see that a Slack message was sent to myself to provision and approve this access. And I can either approve it or I could deny it. And so I approve the access, and then I automatically get a notification and an alert that the access was granted. And now if we look at the Okta logs for this application, we can see that the Conductor One service account had provisioned the access. And when we look at the target for the app, we can see here that it was the IT FAQ app that was provisioned through this process. And then once I look for myself again in Okta, I can see I now have access. If I go back a slide just into our ideal system, visibility was particularly important. If we go and if we notice just the configuration for this in the backend, you can see there are entitlements and accounts kind of in this area. And what this does is through Conductor One, we're able to see all the users who have access to this application. We can see the entitlements that exist and the resources. So we saw for that first ideal system, we saw that we can do just-in-time access. We saw there's automated provisioning. And then after the hour, Okta would then remove access to that system. And so we built the system really to ensure that we have least privilege, that only people who require access are able to get access to a system. But we wanted to do so in a way that was frictionless, that was easy for our users to be able to do this. And users can go into Slack, they can go into the Conductor One web app, they can request access to various methods, and then almost instantaneously are able to get access to a particular application. And so we saw for that first bucket of SaaS applications as a whole, we want to go a little bit deeper now into how we can implement a least privilege program for cloud production access. And this is particularly important for us because this is our riskiest system. We want to make sure that our riskiest system is protected, and we're thinking about it a little bit more than some of our least risky systems. Similarly, just to give a little bit of context of where we started and some of the problems, when we first started, just being a startup, in order to be able to build our product, we had this always-on access to production. And initially, we had 3 roles to choose from. We had junior engineers, which were for interns and for entry-level engineers. We had this engineers role in AWS, which were for some of the more senior and established engineers. And then we had admins that were for system owners. And that worked when we were a 20, 30, 50-person company. But as we became bigger and got into the 400, 500, 600s, it became particularly challenging. And the reason it became challenging was sometimes you have junior engineers for entry-level engineers, but they needed more access than just junior engineers. And so it's very static. There's only real 3 buckets, and there's a lot of nuances in between that we really couldn't meet. And sometimes when you get a new engineer and an engineer requests access to a new resource, the engineer is then forced to wait until someone on our infrastructure team and our DevOps team got to the request and granted that access. But particularly it was challenging also for our infrastructure team as they added new IAM policies and statements to allow for that access. There's a lot of manual work, even for our engineers, to really be able to grant someone access. And so we see the problems we wanted to solve is that senior engineers had sometimes persistent access to production, which is an increased risk, and an account compromise and a takeover could really impact a large amount of our infrastructure. And AWS holds a lot of that confidential data that we really care about and want to protect for our customers and our partners and so on. At the same time, something I previously mentioned, our junior engineers had very limited access and then had to ask our senior engineers to run queries or do certain things that they themselves couldn't do with the role. So we have 2 ends of the spectrum. We have senior engineers who had way too much access all the time. And then we had junior engineers who didn't have enough access and couldn't perform their role. And so there's the risk at one level and there's increased friction and loss of time at the other end. And so quickly, we realized we needed to solve this issue. Engineers needed an immediate and quick way to access our production servers to fix emergent issues and be able to solve problems for our customer quickly. But we wanted to do that while making sure that our production servers are protected because it was the most sensitive and potentially destructive and risky. And so there were a couple of problems we wanted to solve. One, we wanted to get an accurate and complete listing of users with access to production. 2, we wanted we didn't really have a lot of visibility, and going back to visibility, not just into who had access to these systems, but the frequency and the use of which people needed this level of access. We didn't know when a senior engineer was requesting it, how long they really needed it for, what that really meant, and we didn't have a lot of data to go off of. And there was this clear risk of breaches that we've seen just across the industry because of the level of privileged access. And we wanted to really solve for this issue. At the same time, similar to the way that our SaaS applications were working, we didn't have like a clear and consistent and a centralized process to get access, causing engineers to be slowed down. And for RAMP, velocity was particularly important and is still particularly important. And we wanted to enable our engineers and not cause more friction. Just a little bit more context, our engineers work in this pod model, but our access model didn't particularly match our pod by pod operating model. Because we only had these 3 roles, our access model didn't match the different levels of pods that we had across the board. And so we had a lot of problems to be solved. We had this overall goal. And so we needed to think and strategize potential solutions. And so Julian, who is a software engineer on our infrastructure team, really thought through this problem and tried to solve through it. And as Julian was solving and thinking through this issue, we had 3 main goals. We needed a system that can support immediate access for a subset of highly trusted engineers. And so we have engineers who we trust and we want to really give ownership to them, which goes into number 2, where we wanted pod tech leads to be accountable and be owners for their systems and the usage of production access within. And then lastly, we wanted a system that could enable retrospective access reviews to spot anomalies, to spot why people were giving access and why people needed access to such high and critical systems. And so we're trying to build this ideal system. We wanted just-in-time. We particularly wanted just-in-time to be at most for 24 hours. And then after 24 hours for access to automatically and programmatically expire. We wanted, similar to our SaaS tools, our requests to be routed to the right owner. And then if there wasn't an owner, there's some backup approver. And then the resource owner, if they themselves wanted to request access, it would get automatically approved because within that subset of trusted engineers, there was even a smaller subset of even more trusted engineers who were their tech leads of their pods. We wanted to allow for just automatic approval so that they're able to go and debug issues and solve problems. And we wanted this production style access to become ephemeral, and we didn't want standing access to our most sensitive systems. So we can see a demo from.
Just a quick demo to show you how we interact with connector one. So let's say I want to SSH to a production instance. I'm gonna run the following command: devtool SSH to container, and then select environment to prod. So first, the tool is going to detect that I don't have access to production, and it's going to suggest me a role, production role that I can obtain. So I'm just going to press yes here. Then I can select the duration. I'm going to say an hour, and then it's going to ask me why I need production access. So just GMO. And then it's going to call conductor one. I'm going to obtain the new production role. And now I have access to the new prod role. I can say.
And so here, just a couple of things that we can note. Within the CLI, we have the cone CLI, which is the conductor one CLI, and the command line that engineers can use to request access. So previously, when we looked at the SaaS applications, users can go into Slack, users can go into the conductor one web app and request access. We wanted to bring this to where the engineers were working and be able to do that through a CLI. And so you can see here that there's only one production role that is requestable, which is the prod eng infrastructure. And the reason that is because Julian is on the infrastructure team. Previously, when we were thinking about just the 3 levels of roles, I noted that it didn't meet this pod kind of strategy, and our access strategy didn't meet how our pods were operating. But here, we split out the roles, and so Julian is now able to only request the prod eng infrastructure role because that's the team is on, and he's not able to request other prod roles in AWS. And you can see that Julian requested this for an hour, and Connector One takes the request because Julian was the tech lead for this role. It was auto-approved, and then he was able to go and choose some of the services that he wanted to access. And we can see just some of the AWS roles, and then we can see that the prod eng infrastructure role was granted to Julian. Now, if we
just a quick
look now on the back end, we can see the request end. We can see how this role was requested and kind of what's happening here. We can see that this is the request that Julian put in. This was just for a demo. It was an hour. And we can see that Julian created the task. It was auto-approved because he was a tech lead. And then Conductor One goes and then provisions that entitlement into AWS. Now, similarly, if we look at the Octalogs, we could see here that the role, the Conductor One service account provisioned the role and that it was successfully provisioned. We'll then see, as we go up the logs, that Julian was able to then sign into the role and that it was successful. And so through the CLI, Julian's able to request the role. It gets requested for an hour. He's able to then, within the next couple of seconds, able to access the role. And then conductor one, after the hour is over, will then remove the role. And so we've effectively taken away standing access to our most critical AWS roles and moved to the just-in-time model so that we can ensure that our customer data and our most critical infrastructure is protected. And so that's just some of the practical ways that we leveraged this tool to really solve for access and auth for our SaaS applications and implement least privilege for our cloud production access. If we look through just some of the overall impacts and the benefits, we can see that we've had a lot of compliance wins. I know I mentioned that we're moving beyond compliance, but there's still real compliance needs and compliance wins that we care about and are important to us and our team. And so we can actually easily be able to, through Conductor One, perform user access reviews. You're able to gain visibility. We're able to use Conductor One just for overall ticketing, and we can show that we are able to track all access requests for the systems that are leveraging Conductor One. There are real security wins. We can audit who has access to what. We can audit why it was requested. We're able to, as we just saw, take away standing access to our production AWS roles. At the same time, we're able to have compliance and security wins while enabling velocity. We've seen about a 95% reduction in IT effort, particularly from the ticketing process, because tickets don't come in and they actually now get funneled through Conductor One. And so we can see there's overall real compliance wins, real security wins, but we do that not by creating friction, but by making it easier for our users to be able to do what's most important to them and to be able to really complete their tasks and carry out their roles without being slowed down. Lastly, just some of the lessons that we've learned throughout this process. The first one is we have to really scope our problem tightly. It's really hard to just solve access governance and access strategy as a whole than it is to solve just-in-time access for AWS. And so we want to scope the issues that we care most about and then work really from like a critical level until we want to solve for critical problems first, and then move on to solve less risky problems. And so we want to ensure and really identify, as we saw, what the problems were, what our ideal systems are, and be able to, with clarity, be able to define those things so that we're able to then find an effective and efficient solution to those things. Second, something we've learned is it's really important to establish clear ownership of all these systems. As you saw, we have hundreds of systems that we use here at Ramp, and every system, for the most part, may have a different DRI and a different owner. And a lot of the way that we built our access strategy here at Ramp is we want to give system owners the ability to really own their own systems and the data that lives inside those systems. So it's not just one or two teams, but it's teams across the organization that we give ownership to, who can then take that to be able to effectively administer access to their systems. And it's important to define clear ownership. We found that there were a lot of times where even owners didn't know that they were an owner. And so there was a little bit of work to be able to define that clearly. Lastly, onboarding employees to a new system was particularly challenging. We did a lot of work to build the system, but teaching Ramp to be able to, and the users and the employees at Ramp to use this new system was a different challenge in itself. And so at every level, from building, from identifying, and then from implementing and getting our users to be able to really leverage, there's a lot of thinking and a lot of thought that we did in order to be able to build the best system. And so this was really helpful for us. We were able to move forward and move our security posture to a place where we were able to implement just in time for a lot of our systems, implement least privilege, and overall be able to maintain and keep our customers' trust. And that's all for me.